In this lesson, we're going to be talking about dividing monomials. By the end, you should be able to simplify expressions that involve division among monomials and simplify expressions that contain negative exponents. Dividing monomials, we have a couple of rules that we want to kind of keep in mind here. And this first one is called the quotient of powers. And what the quotient of powers tells us is that if we divide monomials with the same base, that we can do a shortcut here. So bases have to be the same, and what we can do is we can subtract their exponents. So let's look at the following example. We have a to the 6th power over a squared. Those bases are both a, so they're the same, and so what the quotient of powers does is that I can just subtract their exponents. So I can subtract 6 and 2, which gives me 4, and we end up with our new exponent, or our new power, which would be a to the 4th power. Now, why does this work? Well, if we expand, so if we look at another example, 4 to the 5th power over 4 cubed, and if we write it in expanded form, we'll have 5 4s being multiplied on the top, and we'll have 3 4s being multiplied on the bottom. And when we simplify, we can cross out things that are the same in both the top and the bottom when there's multiplication all the way throughout. We can form pairs and that cancel each other out. So we have 3 4s that will eliminate with 3 4s on the bottom, leaving us with 2 4s on the top, which would just be 4 squared. 4 times 4 should be 4 squared over, remember the bottom went away, but anytime the bottom completely cancels out, what we're left with is not 0. What we're left with is really 1. So we end up with 4 squared over 1, which can simplify down to just 4 squared. Now, if we look at the exponent of 4 squared, and we look at the exponents from what we had before, we see that 2 is really the difference between 5 and 3. So if I do 5 minus 3, we'll end up with 2, and so that is why we can subtract their exponents. Now, we do have some cases where we don't always start off with quotient of powers. And so we might start off with something known as the power of a quotient. This is when you take a division problem, such as a fraction, and you raise that fraction to a power. And so what this tells us to do is it says distribute the power to both the numerator and the denominator. Okay? Multiply your exponents that are there, and then apply the quotient of powers rule. So then subtract the exponents after that. So we have a divided by, or a to the 4th divided by a, and we have that being cubed. So we have a to the 4th divided by a, and we have that being cubed. And so what this says is it says distribute the power to the top and the bottom. So we distribute it to the a to the 4th, so a to the 4th to the power of 3. Remember that if you're raising a power to a power, you multiply. So a to the 4th raised to the power of 3 becomes a to the 12th power. And then the a on the bottom is a to the 1st power. Well, a to the 1st power raised to the 3rd power. Again, you are multiplying there. And so what you'll end up with is a cubed. So just to make sure that you understand what I mean by this, is we distribute it to both the top and the bottom. So I'm going to raise both the top and the bottom by the power of 3. A to the 4th raised to the power of 3 becomes a to the 12th. And a cubed remains a cubed. Now we have a quotient of powers, and we can simplify this. Again, same base. So we subtract their powers. We subtract the exponents. 12 minus 3, which gives me 9. And so the simplified expression here would be a to the 9th power. So anytime we have a power of a quotient, we're going to distribute that power to the numerator and the denominator first. We'll multiply those exponents that need to be multiplied, and then we'll subtract and do the quotient of powers if necessary. We also have this zero power property. And I'm not going to dive too far into this, into the reasoning behind this, just for the sake of time. But the important thing to know here is that any number raised to the power of 0 is equal to 1. So that means 3 to the 0 power is 1, a to the 0 power is 1, 134 a cubed, b to the 6th, z cubed, g to the 5th, and then all of that being raised to the power of 0, all of that is 1. So anything raised to the power of 0 is 1. It's going to be important for you to know. An important note here, though, is that make sure you know where that negative is placed. When we look at this first one, we have negative 6 in parentheses raised to the 0 power. That is still 1. But if we move the negative to the outside, then what we have is negative 1, because you'll do 6 to the power of 0 first, which would be 1, and then you'll apply the negative to it after that, based off of order of operations. So just be aware of that where the negative is does affect if it's going to be a positive 1 or if it's going to be a negative 1. When we have negative exponents, what negative exponents tell us to do is it's telling us that we need to look at the reciprocal. So we have a to the negative 5th power. What it's saying is don't look at a, but look at the reciprocal of a. So the reciprocal of a would be 1 over a, and then it says raise that to the 5th power. So what we have is 1 over a to the 5th power. If we look at 3 to the negative 3rd, again, that says, hey, it's a negative exponent, so that tells me look at the reciprocal. So instead of 3, we want to look at 1/3. And then the 3 says, okay, now raise 1/3 to the power of 3. So that'd be 1/3 cubed, which would be 1 over 27. If we look at a to the negative 2nd and d to the negative 4th, again, that says, hey, look at the reciprocal of a and d. So if a was in the top, the reciprocal would be move to the bottom of a fraction. And if d was in the bottom, and there's negative exponent, then that says, hey, move d to the top. That would be the reciprocal. So what we end up with is d to the 4th power over a to the 2nd power. The exponent stays the same, stays with the variable. The location of that variable changes because you're looking at the reciprocal. Now why? Why is it that when we have a negative exponent, we look at the reciprocal? Well, let's take a moment to look at what happens when we look at our quotient of powers. So remember that when we did quotient of powers, it says that if they have the same base, we can subtract their exponents, right? So if I subtract the exponents, if I do 3 minus 5, what we end up with is negative 2. So we end up with 8 to the power of negative 2. Now, that's great. However, it doesn't really tell me a whole lot just yet. So let's go back and think about when we broke this up into expanded form. So remember, when we break it up into expanded form, 8 cubed would be 3/8 being multiplied together. 8 to the 5th power would be 5/8 being multiplied together. And remember that you can cancel out anything that appears in both the top and the bottom. So since we have 3/8 on the top and we have 3/8 on the bottom, I can cancel out the 3/8 on the top with the 3/8 on the bottom. And what that leaves me with is, well, everything on the top appeared to cancel out, so that means that what I'm really left with is 1. And 8 times 8, I can simplify that to 8 squared, so it's 1 over 8 squared. So what we see is that when we write it in expanded form, we get 1 over 8 squared. But when we use our rule for quotient of powers, what we ended up with was 8 to the negative 2nd power. So that means that 1 over 8 squared and 8 to the negative 2nd power really represent or mean the same thing. The reason why we use both of them and why we have this, why we go back, why we take the reciprocal, why we do the parts that we did above, is because having a negative exponent is not simplified fully. And so we need to make sure that we know how to read and look at those negative exponents. So remember negative exponents, we are taking the reciprocal. All right. Power of negative numbers, just remember that where the negative is at, if there's a negative and there's no parentheses, following order of operations, we would do the exponent first. So we would do 6 squared first, so 6 times 6, which would give me 36. And then we would apply the negative to that afterwards. So if you're wanting to square negative 6, you need to make sure that the negative is inside parentheses with the 6, and you're squaring all of that so that you end up with positive 36. This is really important, especially when you're typing numbers into the calculator. This is why a lot of times when you just type in negative 6, like the top example here, you get negative 36 instead of the positive 36 that you are so commonly used to saying. So just make sure that you're paying attention to where those negatives go, because it's going to determine the difference between a negative answer and a positive answer, which could be the difference between right and wrong. Okay, so let's look at these three examples that we have here. So we're looking at 5 to the negative second power. This says take the reciprocal, so instead of 5, we want 1 over 5, and we want 1 over 5 squared, so 1 over 5 squared, which simplifies to 1 over 25. If we look at 2, this is 1 over 3 to the negative second power. So remember, negative exponents say take the reciprocal. So we take the reciprocal of 1/3, this becomes 3, and the 2 stays with the 2. So 3 squared, which would give us 9. We do our quotient of power. We do our quotient of powers rule. That means we subtract. So m to the 7th divided by m to the first power would become m to the 6th. And n to the 5th divided by n to the 2nd would be n to the 3rd, because we subtract those exponents. So our simplified expression would be m to the 6th, n to the 3rd. Again, doing the same thing here. K to the 8th divided by k to the 3rd power. You subtract that, you end up with k to the 5th. S to the 2nd power divided by s to the 5th power would be s to the negative 3rd power. The only thing is that we cannot have a negative exponent that's not simplified. And so we need to take the reciprocal of s. So this would just say, hey, make this into a fraction and put s on the bottom. So this would be k to the 5th divided by s to the 3rd power. So this would be saying, again, k to the 5th power is not changing. We take the reciprocal of s, which would be 1 over s to the 3rd power. Simplify that. K to the 5th times 1 is k to the 5th. 1 times s cubed is s cubed. We look at the number 5. Okay. 3 to the 4th power divided by 3 to the 2nd power becomes 3 to the 2nd power, which is just 9. A to the 8th divided by a to the 5th, that's 8 minus 5, which is 3, a cubed. And b to the 3rd minus b to the 1st power, that's 3 minus 1, which is 2, b squared, and so you end up with b squared. Last one here. Okay, we'll simplify the fraction on the top. So 4 divided by 16, that would just be 1/4. P cubed divided by p to the 8th, 3 minus 8, that's negative 5. We can't have a negative exponent, so remember that we're going to have to fix that in just a second. Q squared divided by q to the 5th, that's 2 minus 5, which is negative 3. Again, we can't have a negative exponent, so we take the reciprocal of those. So remember, we have 1/4 times 1 over p to the 5th times 1 over q to the 3rd, which would just simplify to be 1 over 4 p to the 5th and q to the 3rd power. Okay, 32 divided by 8, that's 4. X to the 8th divided by x to the 5th, that would be x to the 3rd power. Y to the 1st power divided by y cubed, that would be y to the negative 2nd power. Again, we can't have negative exponents. So again, the 4x cubed is not going to change. But the y to the 2nd power, y to the negative 2nd power is going to change and become 1 over y to the 2nd power. Remember, anything can be made into a fraction, so I can make 4x cubed into a fraction by placing it over 1. That allows me to simplify. 4x cubed times 1 is 4x cubed. 1 times y squared is y squared, and so we end up with 4x cubed over y squared. Again, hopefully you found this video helpful. Please subscribe to the channel so that you get updates as new videos are released.